Okay, the shaded portion of the semicircle is to be cut from a large sheet of metal. Write down in radians the measure of the angle AOB. So AOB, that's this angle here. So in radians, what's that? Well, I know the full one is 180, so that would be pi, and then take away what I have, which is 2 pi over 3. And that would leave me with 3 pi minus 2 pi over 3. It's just equal to pi over 3. So the area AOB is pi over 3. Pi over 3. Okay, then part 2. Find the exact length of the perimeter of the shaded portion. So the perimeter of the shaded portion, that is the arc length from here to here. So it's all of that arc length plus this straight line. So our arc length, we know L is equal to r theta. So L is r theta. So L is equal to 2 multiplied by theta, which is 2 pi over 3. So L in this case is 4 pi over 3. However, we still have this straight line section here. Okay, so keep in mind what we know about this triangle. We've got we've got B, we got A, and we've got this angle in the middle, pi over 3. We've got 2 centimeters here, and we've got 2 centimeters here. So look, there's a bunch of different ways we could go about finding this missing length x here, but one option would be to use the cosine rule. So I could say that x squared equals a squared plus b squared minus 2 times b times c cos of pi over 3. Just for ease, I'm going to put that in degrees. Pi over 3, it's 180 divided by 3, that's 60. Okay, so x is equal to the square root of all of that. So when I put that into my calculator, I'm going to put in the square root of 2 squared plus 4 squared. I'll just pause the video while I calculate. And it's 60 degrees. Actually, on reflection, that would be much easier to calculate, because I know that this is 60 degrees, pi over 3. I know this is 2 and this is 2. So they're the same length. If they're 60 degrees and all angles have to add up to 180, then that must be 60 and that must be 60, because it's an isosceles. But because now they're all 60, it must be equilateral. So yeah, on reflection, I didn't have to do cosine rule, but look, no harm in practicing it. So what's my total perimeter here? My perimeter is my arc length, which is 4 pi over 3 plus 2. So P is equal to 10 pi over 3. And that's what I'm going to use anyway. 10 pi over 3. Okay, next up, find the area of the shaded portion and hence find the area of the non-shaded segment. Okay, so let's find the area of the whole thing first. So we know it's a semicircle, so you can either use it as a segment or you can use it as a semicircle to find the area. Doesn't really matter what. So if I want to find the area of the full thing, full area, that would be equal to pi r squared will be the area of a full circle, but because it's half a circle, I'm dividing that by 2. So it's pi times 2 to be squared over 2, which is just 2 pi centimeters squared. So that's the full area of it. Now if I find the individual areas, let's say I want to find the area of this part here, that's a sector. So my formula for the area of a sector is, in radians, half r squared theta. So I'm going to do the sector first. So area of sector, area of sector So it's a half r squared theta. That's from page 9 of my tables. A half r squared, 2 squared times theta, which is 2 pi over 3. So that's 4 pi over 3, isn't it? 2 squared is 4, divided by 2 is 2, and 2 by 2 is 4. So it's 4 pi over 3. That's my sector. Now with the area of my triangle. Now I'm just gonna do it in degrees. 60 degrees, I know that's 2, I know that's 2. I'm just going to use a half AB sine C of triangle equals a half AB sine C. So it's a half 2 times 2 sine 60. So 2 2s is 4, 2, and the sine of 60. Sine of 60 is root 3 over 2. So 4 2 sine 60. 2 sine 60 equals root 3. Okay, so shaded area is equal to 4 pi over 3 plus root 3 plus 4 pi over 3, and that gives me 5.92. And then if I want to find the area of the non-shaded section, this tiny little bit here, I'll just take it away from my full area. So non-shaded is 2 pi minus 5.92. That'll be somewhere in the region of 0.36 centimeters squared.